What do you think? Okay, if you have a in G the clique you have, so let's assume you have a clique in G, you have a clique in G, you have a clique C in G. Okay, what it will become, this what it will become in G complement, in G complement what it will become, this C, this C is a clique in G, what it will become, this C what it will become in G complement, it will become independent set. Very good. It will become independent set in independent set, will it will become independent set. This C will become independent set in G complement. Why? See, because it is a clique in G. Okay, you have this graph G. Let's assume A, B, C. This is your graph. Okay, now this is the graph. So you can notice that in this graph, this is a clique A, B, C. This is a clique in this graph. In this graph, this is a clique. Now, what is the G complement? What will be the G complement? A, B, D, C. In G complement, these edges will be gone. These will be gone. See, here you have pairwise adjacent. These are pairwise adjacent, pairwise adjacent. So in the G complement, these edges will be gone. These edges will be gone. So they will become pairwise non-adjacent. Pairwise non-adjacent. So what you will get actually, this is your G complement. DC, DA. This will be the G complement, yes or no? This will be your G complement. So in this G complement, can you notice this A, B, C? This is an independent set. This is an independent set. So this is the idea. Very simple. So finally, I can say if you have a clique C in G, then in G complement, it will become independent set. Similarly, if you have independent set, then it will become a clique. Yes or no? If you have independent set in a graph, then in the complement, it will become clique. Very simple. In the complement, like here you can notice that this BD, this is an independent set. This is the independent set here. In the complement, it will become a clique. So finally, what I can say, or if you tell me one thing, if you have maximum independent set, if you have, let's assume you have S. Let's assume S is maximum independent set. Maximum independent set in G. In G. Then tell me what it will become in G complement. Then this S is what? This is maximum independent set. So this will be clique. This will be the maximum clique. This will be the maximum clique in G. Okay. So remember, if S is maximum independent set in G, then it will become maximum clique in G. And if S is maximum in G complement, sorry, in G complement, Okay. So this will happen. Yes or no? Very simple. Is this clear to everyone? Because if you have maximum independent set, see, it will become a clique, but how can you guarantee it will be maximum? See, if S is maximum independent set, my question is this: if S is maximum independent set in G, because it is independent set, so in G complement it will become, so S is a clique. You know it will become a clique. You already know it will become a clique because here you have independent set. So this S will become clique in G complement. But how can you guarantee that it will be the maximum clique? In this G complement, can we have bigger clique than this? In G complement, can we have bigger clique than S? This is my question. In G complement, can we have bigger clique than S? My question is this: can we have bigger clique than this? Array, do by contradiction. If we have bigger, assume there is a bigger clique. Assume there is a bigger clique. Okay, assume there is a bigger clique. Assume there is a bigger clique. Assume there is a bigger clique than S. Okay, in G complement. You have a bigger clique in than S, you have bigger than S in G complement. Then this bigger clique you have, for example, let's call it this bigger clique M you have. This bigger clique M you have. Then tell me how to get contradiction. If you assume there is a bigger clique, are you understanding the question? See, this S is a maximum independent set. Because this is independent set. Independent set means pairwise non-adjacent. So the vertices in S, they are pairwise non-adjacent. Pairwise non-adjacent. So in the G complement, they will become pairwise adjacent. So in the G complement, they will become clique. My question is, this S is maximum independent set here, but can I guarantee that this will be maximum clique? So in G complement, can we have bigger clique than S? Can we have bigger clique than S? Now you can notice that, assume there is a bigger clique than S. Assume there is a bigger clique than S. Now what will happen? If there is a bigger clique than S, then in G what will happen? Tell me, in G what will happen? This M will be what? This M will be what? This M will be independent set. Yes or no? This M will be independent set. And you can notice this M will be independent set and M has size greater than S. So there is a contradiction. What is the contradiction? And what is the contradiction? So in G, M will be the independent set and M is greater than S because M is bigger than S. So there is a contradiction. What is the contradiction? The contradiction is because we are assuming that S is the maximum clique. S is the maximum independent set. So there is a contradiction. What is the contradiction? Contradiction is this. We are assuming S is maximum independent set. The contradiction is S is maximum independent set. This is what S is maximum independent set. So this is the proof by contradiction. Is this clear? Very simple. The idea is like this. In graph G, you have maximum independent set, maximum, largest independent set. Okay. Then independent set means pairwise non-adjacent. They are pairwise non-adjacent. So in G complement, they will become pairwise adjacent. So in G complement, they will become clique. Now in G complement, this S is a clique. But in G complement, can we have a bigger clique? In G complement, can we have a bigger clique? So if you notice, if we have a bigger clique in G complement, then that bigger clique will become independent set in G. So in G, we will have a bigger independent set. And that is the contradiction. Because we are already saying that S is the maximum independent set. So this is the final conclusion. So if S is the maximum independent set in G, then it will be the maximum clique in G complement. And if S is the maximum clique in G complement, then it will become maximum independent set in G. Is this concept clear? Please tell me. I'm again telling you the proof. Let us assume you have a graph G. This is your graph G. In this graph G, let us assume you have maximum independent set. You have maximum independent set. Maximum means this is the largest. You cannot create larger than this. Agree? So in this G, you have maximum independent set S. This is your maximum. This is the largest. You cannot create larger than this. You agree? So there is no larger. So this is what you have to agree. That okay, there is no larger independent set. There is no larger independent set than S in G. That is the definition. That is the definition of maximum independent set. Now, tell me what will happen in G complement. In G complement, what will be this S? This S will definitely be a clique. This is fine. Is this clear? Because here in this graph G, S is independent set. Means in this S, you have pairwise non-adjacent. You have pairwise non-adjacent in this S. In this S, they are pairwise enemies. I can say they are pairwise enemies. Everyone is enemy of each other. So in the G complement, they will become pairwise friends. There will become pairwise adjacent. So in G complement, this S will be a clique. You know. Now, can you have bigger clique? Now, can we have bigger clique? Can we have bigger clique than this S? So this S is a clique, but can we have bigger clique? Bigger clique M than S? Can we have bigger clique M than S in G complement? In G complement, can we have? So let us assume you have. This is my question. See, S is a clique, that is fine. But now let's see, can we have a bigger clique M than S? Bigger than S, can we have in G complement? So assume you have, assume M, which is greater than S. Okay, means M is bigger. Assume M, okay, which is greater than S, is a clique, is clique, is clique in G complement. Then what will be this M in G? Can you tell me? See, this M is a bigger clique. I am assuming that this M is the bigger clique. Means in this G dash, there is a bigger clique. This S is a clique, but there is a bigger clique M. Now tell me what will happen in G, in G. In G, what will happen? In G, this M will be what? This M is a bigger clique. This M is greater than S, and this M is a clique. So in G, what will be M? In G complement, M is a clique. Then in G, what will be M? M is independent set. M is independent set. Yes, correct. Because in G complement, M is a clique. M is a clique. Means pairwise adjacent. So in G, it will become independent set. So now you can notice there is a contradiction. In G, M is independent set. You are saying that M is independent set. And you also know that M is greater than S. M is independent set. M is independent set. And you are saying M is greater than S. It means what? S is not maximum independent set. It means what? It means S is not maximum independent set. And this is the contradiction. And this is the contradiction. Is this clear now? Let me know. The same thing will happen for maximal. The same thing will happen for maximal. The same thing will happen for maximal. Okay. All these concepts, are they clear? Please let me know. So this is enough for today. So we have seen independent set and this clique and independent set. Like, are you confident that you understood? Did you understand the definition? Did you understand the comparison? Okay, like maximal, maximum, what is the clique, what is the like largest clique number, independence number, largest independent set. So all the concepts that we have seen. Okay, what is the alpha and gamma, what is the alpha and omega in path graph, cycle graph, complete bipartite graph. Okay, so everything we have seen, hypercube graph. So this is the complete analysis. So before going, can we solve this question? Can we try this question before going? Independence number we have to find for G1 and G2. So for G1 and G2, let's find the independence number. First, for G2, what is the independence number for G2? So in this G2, this is a path graph. You already know this is a path graph. Tell me, this is your 1, 2, 3, 4, 5, 6. This is your P6. So the answer will be directly 3. You can directly say answer will be 3 because this is a path graph. So the answer will be what? So the answer will be seal. The answer will be seal 6 divided by 2. Seal 6 divided by 2. This will be the answer. Answer will be 3. Okay. This is the answer. And what is the omega? What is the omega of G2? For this G2, what is the omega? Omega is 2. Omega, the largest complete subgraph. The largest complete subgraph that you can create. Largest, maximum clique, maximum. Okay, so that is your K2. What about this G1? What is the alpha of G1? Alpha of G1. Tell me one thing. If I take this vertex, can I get maximum? Like if I take this vertex, can I take something else? If I take this vertex, can I take anything else? If I take this vertex, I cannot take anything else. So this vertex you cannot put in the maximum independent set. If you want to create maximum independent set, you cannot take this. So this is out of the picture. This is out of the picture. So what is the maximum independent set you can create? What will be the maximum independent set you can create? So this is out of the picture. You cannot take this. So what I can take? I can take, for example, I can take V1, then I can take V5, I can take V2. So actually I can take V1, I can take V2, I can take V1, V2. So can I create like, okay, can I create size 4? Can you create size 4 independent set in this? Can I create size 4 independent set? This is out of the picture. You don't have to worry about this. So can we create size 4 independent set? If I take this, then I can take this, then I can take this. So I think we cannot create size 4. Yes or no? We cannot create size 4. So the independence number will be 3. There is no size 4. You can try, like you can check. Whatever you try, if I take V1, see, if I take V1, then what is the largest I can create? If I take V1, I cannot take V6. Now from the remaining 4, I can take 2 only. From the remaining 4, I can take these 2. If I take this, then I yeah, okay, so 2i. Okay, so I think there will be only 3. What is the omega? What is the omega of G? This. So independent set, the largest independent set you can create, for example, V1, you can take V2, and you can take V5. Okay, so like this you can do. And what is the omega? The omega is 3 because you have a triangle. So like you have a triangle. Do you have K4? In this, do you have K4? Like, can you find K4? Do we have K4? Do we have K4? There is no K4, right? We don't have any K4. So the omega will be 3 and alpha also will be 3. Okay, so this is the simple question. What is the independence number of this graph? Tell me, what is the independence number of a graph on n vertices? Every 2 vertices are connected by A's. Connected by A's. So this is your complete graph. This is the complete graph on n vertices. The independence number will be 1. And what is the answer for this? So alpha will be 1. You can notice the alpha will be 1 and omega will be what? Omega will be n. Independence number of a graph with at least 3 vertices and only 1 edge. What is the answer for this? At least 3 vertices and only 1 edge. There is only 1 edge and at least 3 vertices. Like you have at least 3 vertices. So for example, you have n vertices and only single edge. Single edge you have. And where n is greater than equal to 3. This is the question. This is your part C. So you have total n vertices like A1, A2, A3, A4 and so on. Total n vertices you have, and there is only 1 edge. Then for this graph, what will be the alpha? The alpha will be, you can take all these vertices and you can, so basically you can take all these vertices. So the alpha will be n minus 1. Alpha, that will be n minus 1. This is the largest independent set you can create. And what is the omega? The omega will be 2. The omega will be 2. You can create K2. Okay, so very simple. So this is the answer for this question. So for this question, answer will be n minus 1. That will be your alpha and omega will be 2. Okay, very simple. So in the next lecture, we will study, in the next class, we will study vertex cover, edge cover, covering number. This concept we will study in the next class. Okay.